State the most specific name for each figure. All right, we got four of them here. They're all quadrilaterals, but I could probably be a little bit more specific for each of them. For example, we have a quadrilateral where two opposing sides are parallel, and that's it. That's all I've got. This would be a trapezoid. Now, there's different types of trapezoids. There's a right trapezoid. That's if you have a trapezoid that creates a right angle. That doesn't happen here. What's next? Well, we've got one pair of parallel sides. We've got two pairs of parallel sides. This would be a parallelogram. Parallelogram. Okay. This guy right here. Congruent, 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 congruent. Don't know anything about the angles. Don't know if they're parallel. But what I do know is all four sides are congruent, which means this would be a rhombus. A rhombus is what I took to school one time and went to a different place. Hee hee, joke. And then we have ourselves four right angles. Opposing sides are congruent and opposing sides are congruent. This is a rectangle. So a couple of the ones we didn't hit square. We didn't hit just a quadrilateral. We didn't hit kite. But, I think those are pretty simple, pretty straightforward. Those are quadrilaterals. Fun. Find the measure of each angle indicated. All right, so it looks like in this case I only have to find angle G. Now what I have here is a 1, 2, 3, 4-sided figure, also known as a quadrilateral. The angles in a 4-sided figure add up to 360 degrees. I've been given 3 of those angles. So if the angles add up to 360 degrees, then 65 plus 110 plus 87 plus, I don't know, I'll call it X, equals 360 degrees. Let's combine like terms one at a time. 175 plus 87 plus X equals 360. 175 plus 87, 262, in that order, or not in that order. Did I do that right? That looks good to me. Plus X equals 360. In order to get X all by itself, let's subtract 262 from both sides. X equals 98. But we will say 98 degrees. Okay, 0.6 away from a pretty popular boy band from the late 90s. Or was it just 98 degrees? I think it was just 98 degrees. Nick Lachey. Pretty famous guy. Look him up. Solve for X. All right. What we have here is 4 sides, so that whole thing is 360 degrees. Now, there's 2 ways that you can do this, but let's play dumb. Let's just say that all I know is I have 4 sides, which means everything adds up to 360 degrees. Okay, so 104 plus 10x minus 4 plus, interesting, 104 again, plus 76 equals 360 degrees. So if we combine like terms, I have 104 minus 4 is 100, plus 104 is 204, plus 76, 204 plus 76 is 280. And then I have plus 10x equals 360. 2-step problem, subtract 280. Subtract 280, 10x equals 80. Divide by 10, divide by 10, and x equals 8, which is all I had to do. Now, there's another way that you could do this problem. And let me show you that other way of doing this problem. Okay, if these guys are the same, right, that implies that these guys are also going to be the same. Because what we have here, actually, you know what? Since I'm not given any markings, I'm not definitively given that information. Although, yeah, it's got to be the case. If these guys are the same, then these guys have to be the same. They have to be. So I have 10x minus 4 equals 76. If I add 4, 10x equals 80. Divide by 10, and looky there. 10, 9, 8, 76ers. And two ways to do that problem. Both ways you'll get 8. 8, 8, 8 is great. Solve for x, the figure is a parallelogram. Oh, this is nice. If the figure is a parallelogram, we know a couple things. These guys are parallel. These guys are parallel. Does that help us here? No. What else do we know? These guys are congruent. And most importantly, these guys are congruent, which means we could say 2x plus 15 is equal to x plus 15. Subtract x from both sides because we have x on both sides of the equal sign. 2x minus 1x is just an x. X plus 15 equals 15. Subtract 15, subtract 15. You cancel out, and coincidentally, so do you. So x equals 0. And you might be thinking, no, that can't be right. You can't have 0 distance. Well, I'm not given the distance. X is not the distance. X is just some placeholder for these guys. If I were to replace x with 0, you disappear. And if I were to replace x with 0, you disappear. And you both end up being 15. So 0 is the correct answer because the math ends up the way it's supposed to. So that's how you do it. Solve for x, the figure is a parallelogram. All right, what do we have? We have two angles that are adjacent to each other. In parallelograms, if two angles are right next to each other, those angles add up to 180 degrees. Now, if they were opposite of each other, they would be congruent, but that's not what I have here. What I have is two angles that are next to each other, so they add up to 180. So 80 plus 11x minus 10 equals 180. Combine like terms, so 80 minus 100 minus 10 is 70. So 70 plus 11x equals 180. Subtract 70 from both sides. Subtract 70 from both sides because it's a two-stepper. 11x is equal to 110. In order to get x all by itself, divide both sides by 11, divide both sides by 11, and x equals 10. So that's how you do it. Okay, make sure in this case you set them up equal to 180, not set them equal to each other. Very easy to make that mistake. We didn't make it, so we got it right. The figure is a parallelogram. TE is 4 plus 2x. So what's TE? Your TE, you are 4 plus 2x. EV is 4x minus 4. Now, in a parallelogram, the diagonals bisect each other. In other words, UE will be congruent to ES. But most importantly for us, TE is congruent to EV. So the way I set this up is 4x minus 4, because EV, is congruent to TE, so equals 4 plus 2x. So I have a variable on both sides of the equal sign. So what I'll do is I'll subtract 2x from both sides minus 2x, cross U out. 4x minus 2x is 2x. Drop down the minus 4. Drop down the equal sign. Drop down the regular 4. 2x minus 4, let's get rid of the minus 4 by adding 4 to both sides, like so. 2x equals 8. Divide by 2, and x equals 4. So circle that and call it a day, right? Wrong, because it's not asking us to find x. It's asking us to find TE. TE is 4 plus 2x. X is 4. So TE is 4 plus 2 times 4. 2 times 4 is 8, like so. And 4 plus 8 is 12. And so TE, tight end, equals 12. A little football reference for you football heads. Speaking of football head, Hey Arnold, remember that show? Like and subscribe. Solve for x, the figure is a trapezoid. All right, what I have here is I have a median, okay? The median is basically exactly what it sounds like. It's the middle part of a trapezoid or a parallelogram or whatever it is that you're dealing with, whatever quadrilateral that you're dealing with. So if this is a trapezoid, we have two parallel sides. Doesn't mean that they're parallel angles or parallel or they're congruent. They're just parallel. But this is the median, which means it's directly in the middle. The formula to find the median is 1/2 times the sum of base sub 1 plus base sub 2. So if we were to call UM, and it doesn't matter which one your base sub 1 is or base sub 2 is, so we'll call you base sub 1, base sub 2. If I were to use this information to solve for x, I would say that the median, m, negative x plus 21, not plus m, equals 1/2 of base sub 1, which I called 17, plus base sub 2, which I called 11. So PEMDAS says let's do everything inside the parentheses first. So 1/2 of 17 plus 11 is 1/2 of 28. Negative x plus 21. 1/2 of 28 is 14. Now I have a two-step equation. Let's subtract 21 from both sides, minus 21. Negative x equals negative 7. And if negative x equals negative 7, then positive x equals positive 7. So there's our guy. And if we wanted to check our work, negative 7 plus 21 is 14. So this length would be 14, and 14 happens to be completely in between 11 and 17. It's the average, essentially. And that's what the median gives us, right in the middle. Solve for x, the figure is a trapezoid. Actually, let's be a little bit more specific. See how these guys are congruent? This figure is an isosceles trapezoid. And the rule for isosceles trapezoids is not only do they bisect each other, but the diagonals are actually congruent. If these weren't isosceles trapezoids, they wouldn't be congruent. But in this case, these two, EC and FD, are congruent. So since it gives us EC and FD, I could set those guys equal to each other. So EC is 20, FD is 5x minus 10, and I have a regular two-step equation. Okay, 5x minus 10, let's add 10 to both sides, cross you out. 20 plus 10 is 30. Drop down the equal sign, drop down the 5x. In order to get x all by itself, we divide everything from 5. And let's flip it around. I like my x on the left. 30 divided by 5 is 6. So x equals 6. And if I wanted to check my work, I could do 5 times 6 is 30. And 30 minus 10 is 20, just like EC is already. So there you go. Isosceles trapezoid because these two guys are congruent, which means the diagonals are also congruent. Bada bing! The figure is a trapezoid. Specifically, this is an isosceles trapezoid. I should have put those markings there. But when you have isosceles trapezoids, there's some news. Angles next to each other that are not on the same side, or I guess these would be considered bases. So angles that are on different bases that are next to each other add up to 180 degrees. So what I can do is I could say 6x minus 22, this angle right here, plus 8x plus 34, angle R, both of those add up to 180 degrees. So I can combine like terms, 6x, 8x, 14x, minus 22 and positive 34 is 12. That's going to equal 180. And I have myself a two-step equation. Okay, let's get rid of this 12 first by subtracting 12 from both sides. Subtract 12 from both sides. 4x equals 168. It's 14x, not 4x. Boy, would that change things. Divide everything by 14. Divide everything by 14. And x is going to equal 12. Circle that and call it a day, right? Wrong. It's not asking for x. It's asking for the measure of angle r. And the measure of angle r is 8x plus 34. X is 12. So the measure of angle r is 8 times 12 plus 34. 8 times 12 is 96. 96 plus 34 is 130. So the measure of angle r is 130 degrees. Now, if you're like, oh, I don't believe you, then what you could do is you can plug in 12 to x up here and get 6 times 12, which is 72. 72 minus 22 is 50. So if this is 50 and that's 130, then those guys add up to 180 degrees, which is what I originally said it would. Okay? So that's how you add adjacent angles of a trapezoid if they're on different bases. Find x. What we have here is we have a rhombus. There's a couple ways that we can approach this, but what I see is it gives me a rhombus that's cut in half right here. And by cutting a rhombus in half, you are creating an isosceles triangle. Why does that matter? Well, because if you are 8x minus 3, then you are also 8x minus 3. You're 106, and these are three angles of a triangle. So the three angles of a triangle add up to 180 degrees. So 8x minus 3 plus another 8x minus 3 plus 106 equals 180. Now, if you're wondering, well, couldn't I have just done 2 times parentheses 8x minus 3? Sure. But, I set it up this way, and I'm not stopping. I'm not erasing a thing. So I have 8x, 8x, that's 16x. We're combining like terms. I have negative 3, another negative 3, which is negative 6, and 106, which is a perfect 100. That equals 180. Now I have a two-step equation. First, subtract 100 from both sides. I think I can handle the math here. 180 minus 100 is 80. 16x is on the left still. In order to get x all by itself, we divide 16 from both sides. And 80 divided by 16 is 5. We're being asked to find x, nothing more, so x is 5. And if you wanted to double check your work by plugging in 5 for x, and you get 40 minus 3 and 40 minus 3, and then all that up, you get 180, but I'm gonna leave it like that. Okay? Dunzo. Find x. All right, what do we have here? We have, a rhombus. This side is congruent to that side, which means these two guys are equal to each other. So let's set that up. 8 equals x plus 1, a one-step equation, minus 1, and x equals 7. Very straightforward, very simple problem. That's how it's done. Find the measure of RST. All right, where is RST? RST. Ooh, okay. What I have here is I have a rhombus cut in half. Now, what I know is when you take a rhombus and cut in half, you get yourself an isosceles triangle right here. Why does that matter? Because if you're 5x minus 5, then you are also 5x minus 5 because isosceles triangles have the same exact base angle right here. So I can set up an equation where this angle plus this angle plus this angle equals 180 degrees. So let's do that. 5x minus 5 plus 5x minus 5 plus 5x plus 10 equals 180. Good news. -5, -5, and positive 10 all cancel each other out. -5 plus -5 is -10. -10 plus 10 is 0. Nothing. 5x plus 5x plus 5x is 15x. And now I have a one-step equation. All I have to do is divide both sides by 15. And x equals 12. Done? Nope. Because what I have to do is find the measure of angle RST. What I know is this guy is 5x minus 5. X is 12. So that guy is 5 times 12 minus 5, which is 60 minus 5, which is 55 degrees. So this guy is 55 degrees. Now, since this is a rhombus and this diagonal cut this guy in half, that means both of these are 55 degrees. And in order to find the whole thing, I take 55 and add it to itself, meaning that the measure of angle RST, which was that whole thing, is 55 plus 55, which is 110 degrees. So this one required you to think outside the box a little bit. Or should I say, think outside the rhombus. Yes. Yes, sir. Find the missing measure. What do we have? We have these two guys are congruent. These two guys are congruent. Oh, adjacent sides are congruent. This is a kite. You can imagine putting a line here and a line here and pretending there's a string and a couple bows and you have yourself a kite. Now, what's important about this is these two guys are what's called the vertex angles, which means F and H are the non-vertex angles. So why do we care about the non-vertex angles? Well, because they're congruent. So if my job is to find out what F is, I know H is the same. So if I call you X, then I can call you X. Now, how does that help me? Right now, it doesn't. But what I do know is this is also a quadrilateral. And quadrilaterals add up to 360 degrees. So 66 plus x plus 70 plus x is 360. So let's set that up. 66 plus x plus 70 plus x is 360 degrees. Combined like terms, 66 plus 77 is 136. X plus x is two of them, so 2x. And now I have myself a regular old two-step equation. If we subtract 136 from both sides, minus 136, 2x is going to equal 224. Divide both sides by 2, and x equals 112. Now, we want to find out the measure of angle F. We called the measure of angle F x. So, the measure of angle F is x, which means it's 112 degrees. All right, so again, we add ourselves a kite. These two guys, the non-congruent angles are going to be congruent. They're called the non-vertex angles. And so we just set it up equal to 360 and got it. Dunzo. ME equals 20. Me is 20. I wish. What do I know about this shape? Oh, these two guys are the same, and these two guys are the same. We have a kite. The diagonals of a kite bisect each other, which means you guys are the same. Doesn't help me here. You guys are the same. That does help me here because it says that ME is 20. So if ME is 20, that means EK is 20. And MK, Mortal Kombat, is found by adding 20 plus 20. According to this calculator that I have right over here, MK is 40. Find X. What do I have? I have these two guys are congruent and these two guys are congruent. We have a kite. Now, what information am I given? I'm given 50 degrees right here and 8x plus 2. And these guys are created by taking CE, which is technically a diagonal of this kite. What do we know about the diagonals of kites? Well, the diagonals of kites bisect the angle that it goes through. And if things bisect angles, that means this angle and this angle are exactly the same measure. So I can say 8x plus 2 equals 50 because they're the same. So now I just start out with the two-step equation, minus 2, drop down the 8x. 8x equals 48. In order to get x all by itself, divide both sides by 8, divide both sides by 8, and x is 6. And that's all we had to do here was just find x. I don't have to plug it into anything. If I wanted to check my work and do 8 times 6, which is 48, 48 plus 2 is 50, it looks like I did it right. But yeah, the diagonals of kites bisect the angle. Pretty nice. Find the measure of angle Z. All right, there's Z. So what I have is I have the fact that 7x minus 4, 5x plus 20, they oppose each other, and I have 105. So this problem is not near as simple as I wish it was. This is what I know. These two sides are congruent. These two sides are congruent. This is a kite because the sides are next to each other, not opposing each other. Now, when you have a kite, okay, the angles in between the non-congruent sides are called non-vertex angles. And these angles are equal to each other. So this is what I'm going to do. I'm going to find x by setting these two equal to each other. Once I have x, that allows me to find out the measure of both of these angles. Does that arrive me at my answer yet? No. My job is to find that angle. So once I find out this angle will be the same. I have 105, and I would have 3 angles in a quadrilateral, and the 4 angles in a quadrilateral add up to 360. So I have to start out by setting these guys equal to each other first, finding out what these are, and then I can finally take care of Z. So 7x minus 4 equals 5x plus 20. I have x on both sides of the equal sign, so let's subtract 5x from both sides. Let's subtract 5x from both sides. 7x minus 5x is 2x. Drop down the minus 4. Drop down the equal sign. Drop down the 20. I can add 4 to both sides, like that. 2x equals 24. Divide both sides by 2, and x equals 12. Again, that's helpful because now that I have x, I can find out both of these angles. Now, they're both going to be the same, so it's not like I have to plug in 12 into both of these and solve them separately. No, if I just find the easier one, like this guy, and do 5 times 12, right? 5 times 12 plus 20, that gets me 60 plus 20. This is 80. So you are now 80, and you are also 80 because you two guys were congruent. Finally, I can figure out what Z is. So I will actually call this Z, and what I know is that this is a quadrilateral. And this angle plus this angle plus this angle plus this angle is going to equal 360 degrees. So 80 plus 80 plus 105 plus z is 360 degrees. If I combine like terms, 80 and 80 is 160. 160 and 105 is 265. 265 plus z equals 360. Subtract 265 from both sides. Subtract 265 from both sides. Z equals 95. So you're 95, which means after all of this, I can finally say that the measure of angle Z is 95 degrees. So this one required a little bit of extra thought. But these are the types of problems that I love. You have to kind of look at what you have, figure out what you have to do, and sometimes it's not as simple as doing one mathematical process. In this case, we had to do 3. But it was great, and it was fun. Find the area of this triangle right here. Looking at this triangle, it doesn't really look like it's as obvious as it is. But if I were to take this triangle and spin it around and make it look like this, where now I could say that this whole thing is 9 yards and this is 6.4 yards, it's a little more obvious what I have. The area of a triangle is 1/2 of base times height. Now, the height is always going to be a perpendicular line going straight up and down to a base. Here, I don't really see the height because you were like, oh, the height should be up from here to here, but it doesn't matter. Any way you spin a triangle, you can get your height. So by taking my triangle and kind of laying it flat so that the 9 yards is flat on the ground, I can see the 6.4 as going up and down. So you're my base and you're my height. So I can say that my area is 1/2 of my base, which is 9, times my height, which is 6.4. Okay, 1/2 of 9 times 6.4 is 28.8. Now, before I circle that and be very happy, we're talking about the area here. Okay, the area is always given in units squared. So I'm going to make sure I say square yards for this guy right here. Okay, depending on your teacher, you might have a teacher that's like, oh, I only care about the number. I really don't care about this part. But you really should say that the area is whatever units squared. Feet squared, yards squared, square inches, square meters, whatever it is. Okay? So that's how you find the area of a triangle. Sometimes you have to spin it around in your mind, which I did. Find the area of this trapezoid right here. All right, the area of a trapezoid is given to us by the formula 1/2 times the height, parentheses, base sub 1 plus base sub 2. This trapezoid is kind of lying flat already, and it gives us the height right there, and it's 5. Which one's base 1, which one's base 2? Doesn't matter. Doesn't matter at all. Okay? So the area of this guy is going to be 1/2 of 5 times base sub 1, which I called 6, plus base sub 2, which I called 3. All right, so 1/2 of 5 times 9. This is probably one that I can do without the use of a calculator. 1/2 of 45 is going to be 22.5. Yeah. Now, before you circle that and call it a day, it's asking for area. And whenever you're being asked for the area, you should always include the units, but square them. Okay, so this is miles. So we're going to say 22.5 square miles. All right, don't ever just say 22.5. Don't say 22.5 miles. It's 22.5 square units. Okay? So we're done. Trapezoid. Write the name of each polygon. Now, polygons get their names by how many sides they have. So let's count the sides and name them. 1 side, 2 side, 3 side, 4 side, 5 side, 6 sides, 7 sides. A 7-sided figure is called a heptagon. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is a decagon. 10. Decagon. Now I'm marking the sides so I don't accidentally overcount. So these little marks doesn't mean necessarily that they're the same. I mean, in this case, they look like they are. I'll put little check marks now. 1, 2, 3, 4, 5, 6, 7, 8, 9 is a nonagon. And last but not least, this weird looking creature at the end here is 1, 2, 3, 4, 5, 6. 6 sides, hexagon. So when you do problems like these, when you're naming things and you're just asked to name the polygon, you don't care if it's regular, which means all the sides are exactly the same, or not, unless they want you to be specific. Technically, this is a regular heptagon because all the sides are the same. I technically wasn't told that, but it's a little obvious. This is not regular. These are not regular. But again, all we had to do was name them, and so I did. State if each polygon is concave or convex. The difference between a concave or a convex is if you have all of the angles where the interior angles are less than 180 degrees, it's convex. Now, I know something is concave when it looks like part of the outside caves in. So this guy is concave. Does this cave in a little bit? Yep, concave. Does this cave in at all? Nope, convex. That's the difference between the two. That's it. State if each polygon is regular or not. A polygon is regular if all the sides are congruent and all of the interior angles are congruent. So you look like you are all congruent, and you look like you're all congruent. So I would say, yeah, that's regular. You, no. And I don't even have to mark anything. That's obviously not a regular shape. Okay? So regular, not regular, dunzo. Find the interior angle sum. The interior angle sum is a fancy way of saying, if I were to add up all of these angles, how many angles live inside the whole thing? Well, there's a formula for the interior angle sum. S equals 180 times the number of sides minus 2. N here stands for the number of sides. So what I do is I count up how many sides I have. I substitute N with that number, do a little bit of PEMDAS, and I have my answer. So you are 1, 2, 3, 4, 5 sides, so N is going to be 5. So using the formula for this guy, I have S equals 180 times 5 minus 2. In other words, 180 times 3 is 540. So the angles of a pentagon, which is what I have, add up to 540 degrees. How many sides do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So N equals 12 in this case. So the sum of all the angles is going to be 180 times 12 minus 2. So the sum is going to equal 180 times 10, which is 1,800 degrees total. Okay? So there you have it, interior angle sum of a polygon. Pretty simple formula to use. Dunzo. Find the measure of one interior angle. We are given a regular 1, 2, 3, 4, 5, 6, 7 octagon. So we are given a regular octagon, where all of the angles are exactly the same. So this is what we have to do first. In order to find one of the angle measures, I have to find the angle measures of this whole thing, which requires us to use the interior angle sum formula, that guy right there. 180 times the number of sides minus 2. So S is going to equal 180 times 8 total sides minus 2. 180 times 6 is 1080. Like the snowboarding game for Nintendo 64. Now, this is the degrees of everything. If all of these add up to 180 degrees, that means 1, 2, 3, 4, 5, 6, 8 of the same exact measurement, 8 of the same angle. So I will say 8A for angle equals 1080 degrees. Divide both sides by 8, and you end up with 135, which means each interior angle is 135 degrees. And the only reason why we were able to do it this method is because this is a regular polygon. If it's not a regular polygon, that's going to require a little bit of extra thought. But since this was regular, it made life a whole lot easier. So we're done. Find the measure of one exterior angle. All right, there's a rule that says the exterior angles, and if you're like, what's an exterior angle? If you were to take each side and keep going with the side, the exterior angle is the measure there. So if I were to do this all the way around, it's asking me, what's the measure of one of these? For every single convex polygon, the exterior angle sum is always 360 degrees. So what I have to do here is I have to find out how many angles there are. So the way I do that is find out how many sides there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 sides, which means there's 9 exterior angles. So I will call an exterior angle X for exterior. And since there's 9 exterior angles and they all add up to 360, I'll say 9x equals 360. Divide both sides by 9, and x equals 40. So each exterior angle is 40 degrees. And we can kind of see that. I know we're not supposed to look at a picture and estimate, but we could see that if I were to put a bunch of these, they would each be 40. And if I were to glue them together, I would get 360 degrees. So that's my guy. Find the area of the regular polygon. All right, so the area of a regular polygon is found by multiplying 1/2 times the perimeter times the apothem. Now, if you're thinking, isn't apothem like a vermin that lives outside at night and is really gross looking? No, that's a possum. We're being asked to find apothem. So I like that joke. That's a good joke. What is an apothem? An apothem is basically a side bisector that's going to be perpendicular to that side and hits the center. So this right here is my apothem. And what I have is one of the side lengths. One of the side lengths is 12. All right, well, in order to find the perimeter, I have the apothem is 14.5. That's the apothem. In order to find the perimeter, I have the fact that you're 12. There's one side, 2 sides, 3, 4, 5, 6, 7, 8. So the perimeter is going to be 8 times 12. So the area is found by multiplying 1/2 to 8 times 12 times 14.5. All right, so I'm going to go off to the side here and pretend like I'm not going to plug this into a calculator. And I did this all in my head, and I ended up getting 69.6. Nice. Now, do I have any units? No. If I had units, I would say square units. So I'm just going to put square units, square U anyway. I'm allowed to do that because it's area. But that's how you find the area of a regular polygon. So yeah, fun, fun, fun. Apothem. Find the area of the regular polygon. Well, what do I have? I have a 1, 2, 3, 4, 5, 6-sided shape. Okay. I know that the area of a regular polygon is 1/2 times the perimeter times the apothem. Now, this is the apothem, so I know that you're going to be 5√3. Gross. Perimeter. I don't know what the perimeter is, but I do know that there are 6 sides and each side is 10. So the perimeter is going to be 6 times 10, and the area is going to be 1/2 times that. So I should be able to do this without a calculator. 1/2 times 6 is 3. So I have 3 times 10 times 5√3. 3 times 10 is 30. So 30 times 5√3 is going to be 150√3. I don't have any units, so I could say units squared. All right, so that's how you do it. √3. Can't forget √3. Ooh, that was a close one. Ooh.